Hi, Rohi.
Hello.
Okay, maybe what we can do, Rohi, we can give it a start, let others join in. Yeah. So let's continue until the last session, right? We have already looked into some of the basic things that we did with SQL. If you remember, we have looked into, let's say, where clauses and group by and things of that sort. So that we have already covered there, right? Let me just do one thing. Give me 1 minute. So that we have already covered. So that is not an issue. Okay. Yeah. So that part we have already covered. So let's just try to continue and let's look into more functions. So what we are going to do now is that we are now going to look at a series of functions that we are going to use. We have understood where clauses, we have understood table and column aliasing, we have understood the positioning of where the where clause should be, where the group by should be, where the order by should be, and so on. Once we have done that, now let's continue with another important aspect, that is the functions. And functions are something which is really, really important because functions are something which we are going to use day in, day out. Okay. So part of the data preparation process, part of the data analysis process, we need to make sure to be using a lot of functions, right? We need to be using a lot of functions, which by means of which we are going to do the operations, okay, specifically the activities which is going to achieve the results that we are looking for, right? So that's the target here. So our intention to use the functions is to have something done, okay, and that something, right, that something will be defined by how usually, okay, not always, okay, usually that is defined as how we would like to look at our data or how we would like to output our data, right? So majorly the functions that we make use of is going to change, it is going to modify, it is going to represent the output that we see on screen or the output that we would like to export out of the database. Okay, so that's the main intention. Keeping that in mind, let's see a few functions. Okay, so for example, I'm going to just do a select star from students. Okay, so if I do a select star from students, I can see every information which is there in the students table. Now what I would like to do, example given, let's say that instead of printing the name of the students, let's say if I do a select name from students, so obviously I'm going to get the list of the name. What I would like to do is, let's say, let me just do a control L, and then I can say select a very simple function, something which you have already seen, okay, as student name. Okay, so we can do an uppercase, right? So we have done an upper or lower function by means of which we can convert this string into uppercase and lowercase. Now let's just use this and let's just try to do something more. Okay, so what we can do, right? It's kind of a function which we can use to, let's say, uh, concatenate values, okay, along with each other. So what we are going to do is that we are going to say concat. Okay, we are going to use a function called concat, and we are going to do uh, um, maybe I'm going to say uh, name is equal to comma and this, right? So in this way you can say I've used a function called concat, and using that function what I've done is I've simply concatenated this part of the text. Okay, this part of the string is concatenated. Okay, this is a very useful thing to do. Okay, so this is really very useful thing to do because now using this kind of techniques I can play around with the data, right? And I can prepare the data as I want, right? So clearly what I am essentially doing is I am simply preparing the data. That's all I'm doing, right? So usually what happens is I'll just give you a quick brief. You have some kind of a function, okay? You have some function, okay, which looks like this, and basically the definition of the function, usually this is the case that you have one or two parameters. So you can have a function which has multiple parameters as well. But usually the most common type of functions that we use in any database is first of all a function which takes two inputs. So this is one input, this is another input. Okay. And both of these inputs are separated by comma. Okay, so you have 1 comma 2. Okay, and then it is going to return you some output. In the same way, the other version of a function is where you simply have one input, let's say here, and it is going to give you some output. So this is the most common version of function that we use. There, however, are other functions as well, which over a period of time has evolved to such an extent, based on the database that we're trying to do, that it can accept n number of inputs as well. So it is not limited to one or two inputs. This n can even be, let's say, 5, right? This n can even be, let's say, 7. Okay, so you can give 7 inputs. If this is not already, however, let's say possible, it is not at all going to be a problem, because now I can, I also have the functionality. I also have, let's say, the option, okay, the option that I can have a one function, let's say f1, inside which I can call f2, and inside which I can call f3. Okay, this is exactly what we have done over here. So we have one function over here, okay, concat function. This is starting here and this is ending here with this bracket. And within this function, there are two inputs that we have given. One input is the string, okay, is a simple string input. And the second is actually a function. Okay, this is actually another function. So what it does is this is string one, or this is input one, and then this function is going to return string two. Okay, str2. Somebody somewhere inside the database, in the code of the database, somebody has already written a code for this concat function in some programming language in which MySQL is created. Most often than not, these databases, FYI, are created using languages like C, C++. So I'll assume that MySQL is also written in C, C++, because that's the only way you make the databases so fast and so consistent and so reliable, right? So somebody in the C or C++ code base of MySQL has already written a function called MySQL, where you have two functions, where it takes two inputs, I'm sorry, and then this function is going to return some output. Okay, and that output is as simple as the one that you can see on the screen. So it is clearly evident that I can combine a lot of functions. Okay, it's not limited to usage of two functions. As I said, I can use another function on top of here as well. So let's say if I can do that. So for example, what I can do is that I'll simply use this function, and then what I'm going to do, I'm again going to apply, okay, let's say lower, right? So I can do this as well. In this case, you can see the outer function is lower. Then inside lower function, I have a concat function. Inside the concat function, I have two inputs. One is the name and the second is the upper of the name column. So ultimately, everything is getting converted into lower because I've used a lower function, which is at the outside of all the functions, right? So that's exactly what you can do using multiple functions. You can use multiple functions, okay? But there are other ways of doing the concatenations as well. There are other ways to do the same thing as well. Okay, so for example, what I can say is that let me just clear the screen and let me again open this query, right? So let me just open this query and I am just going to say, I'm just going to say name, right? If I do this, this is also a supported kind of an operator, which is sometimes really supported in the database. Okay, in some of the databases this is really supported, but in this case, as we can see, it is not really supporting. It is treating this double line thing as kind of an operator, and it is trying to find some mathematical relationships between this. So inline, we can do concatenations of this sort as well. In some of the databases, it is supported, but in MySQL, most probably this is not supported. That's why even if I use a plus sign, it is not doing anything. Okay, so instead what I can do, maybe select start from students, let me do, and I can clearly see there is an age and there is a GPA, right? So if I just want to find out the double of age, okay, so what I'm going to do, age plus age from students. If I do this, okay, then as you can see, I am able to do the mathematical calculations as well in line, right? So in this way, I am able to do the mathematical calculations. I'm sure in MySQL database, there may well be a function to find out the mean, median, or mode. So in that case, what I can clearly do is that I can simply use a function. Let's say I would just like to find out the mean of the age. So I'm going to find it like this. And then, of course, you know that I can join tables and I can also figure out other things, right? So let's say I can also figure out things like how what is the mean age of students, okay, the mean age of students in each and every course, right? We have already done that in the last class, if you remember, right? So these are things that I can clearly do, right? I can clearly do that. Now one more very interesting thing, or one more very interesting function, is something like this. Let me just clear the screen and let me do a select star from course. I think it is course, not courses. So let me just correct this. So this is course, right? So what I would like to do, right? What I would like to do is that I would like to only print, okay? Only I would like to print the first, just a moment. I would just like to print only the first, let's say, word in the name of the course. Okay, I just want to print the first word, okay, in the name of the course, right? So what I am going to do is that I can just say that I would just like to get the first four words, let's say, right? So what I'm going to do, I'm going to use a function select substring. Okay, I'm doing a sub of string. So there is a string, I'm taking a part or a sub out of that string, and I'm going to say I want a sub of what name. Okay, and it should start from an index of 0. Okay, so start from an index of 0. In MySQL as well, the indexing starts from 0. Okay, so I'm starting from 0 and I'm going up to, let's say, 4 from course. If I do this, this is what it is printing, right? It is not giving me any proper output. Why, I don't understand. Let me just see if there are other options as short name. No, it is not giving me anything. So let me just clear the screen and name. Right, I'm taking name and I'm doing a subsequent. This should work. I don't know. Maybe I have done some mistakes. Let me check the documentation. Let me just check the documentation 1 minute. Hmm. Substring command in MySQL. Substring command in MySQL. Let me just share this page with you. And what I'm doing is MySQL substring function. Okay, let's see what it is doing over here. So let's see. Should be able to get this. I hope you can see my screen, right?
Yes.
Okay, so it is giving it inside the bracket as extra. A string start length. Yeah, that is exactly what I'm doing, man. What is wrong here? What is wrong? There's nothing wrong in here. That is exactly what I have done. Let me see. Select substring as shortening from course. No, there seems to be some problem. I again tried that function, but it did not work. Maybe I'm really doing something mistakes. Some very stupid mistakes I'm doing. Let me just see one more page and then maybe we'll be able to find out. It seems to be quite slow today. Okay, let me do this in some other laptop. Mhm. Oh, I think no. Um, mm, mm, mm. Somehow this substring thing is not working on the table. Why is that so? Something I'm not able to understand. Okay, let me explore this. Let me find out if this really works out of a table or not, because all the examples I see are very weird. Let me see. Yeah, this is a good example there, Rohi. But then the point is that if you look at this example, right? Let me just do a new screen share. Give me a moment. Let me just reshare my putty window. So what I'm saying is, if you look at this, what it is doing is, you are, just a moment, let me just take that command from your chat. Yeah. So I'm taking the command from your chat and I am going to paste it over here. So it is something like select, okay, a sub str and then some text, okay, comma 4,3. Okay, if I simply do that, I should be able to get the output. I missed a space over there, right? So I'm able to get that, no problem. Okay, so 0 until 3. Okay, so I believe this must start from 1. That was the mistake. Yeah, I got the problem now. I got the problem. It should have been starting from 1. The indexing starts from 1 and not from 0. Not sure how or when, which version this has changed. So it is starting from 1 now. So that was what the problem is. The indexing was the problem. It is starting from 1 and not from 0. Okay, so I think I have got it now. The important thing to note over here is that this kind of substring function is really going to help you extract data, and then you can use this and the length and kind of combination of things, to figure out even more things, right? And that is going to help while during the data preparation, right? Let's move ahead. Let's do some more functions. Okay, let's look at some more functions. Okay. Okay. Now what I'm going to do is I'm going to show you a very quick function, or I would not call it a function. It's not really a function. It's kind of an option that we can do. And this option is going to tell us um, if let's say we have a table that is a very big kind of a data set, okay, a very big kind of a data set, okay, you have a very big kind of a data set where you have a lot of data, let's say, okay, and let me just insert a few more fields there, because I know that we can insert as many fields with the same value as well in the table, right? So if I just continuously run this query, then I should be able to see that I have entered a lot of values now in the table, where a lot of values are actually duplicates, right? So this is okay. What I just wanted to show you is that if imagine you have a table which has, let's say, 100 or 200 rows, it will be very difficult for you to scroll through the screen and look at all the data. So similar to pandas, right? When we were doing Python, we were using the pandas library to look at a data set, where we were using functions like head, right? So in the same way, if I would like to use a head function, okay, if I would like to use a head function which is only going to return me the top 10 rows, okay, so I'm going to limit my output to the first 10 rows. Then what I'm going to do, what I can do is that I can simply say limit 10. Okay, so it's just going to show me the first 10 rows. Okay, I can also use a concept called offset with this, and then it is going to uh, randomize the output. Okay, how is it randomizing the output? Is because now it is starting at an offset of 5, and then it is doing a limit of 10, right? If you know what I mean. So if I just remove all of these things, okay, look at what is happening. So this is the first student, this is second, third, fourth, and fifth. Okay, so this 53633 student name Anna. Okay, this is the fifth uh, student, right? So if I now again execute my query, what it is doing here is it is ignoring the first, the second, the third, the fourth, and the fifth, and from there it is starting. So it is printing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 rows are printed over here, right? Why? Because I have given it an offset of 5 and then a limit of 10. Okay, so clearly we have these kind of options by means of which we can do the sampling of the data, right? Now we have some other ways of doing the queries as well. Okay, so we have already seen cases where we have joined two tables, right? We have seen cases where we were able to do an equi-join. Okay, we were able to join two tables and we were able to get the common part out of it. Okay, then we looked into left join, where we got all the data that is an intersection as well as from the left table, and then we have looked into right join, where we have got all the data from the right table, right? And then we have also seen full outer join, and we have understood the concept of full outer join, but in MySQL there is no such operation like a full outer join, so we could not execute our query, which is okay. We will look into that later. But what if, okay, what if I have an SQL query, which is something like this? Okay, I have a query, let's say this is query 1. Okay, and this query is, let's say, selecting something from some table, where I have a where clause where I would just like to pass, okay, as an input. Okay, in this where clause I would like to pass the input from another query, let's query q2. Okay, so without doing a join, will I be able to do this? The answer is yes. So I can execute q2, right? I can take a list from here and simply pass this list of, okay, list of inputs, okay, list of inputs from this query. The output of this query being a list of input can be passed over to this where clause, and then I should be able to execute q1 and I should be able to run that, right? So how do I do that is a concept known as inline subqueries, or also known as inner queries. Okay, inline subquery, otherwise known as inner query. It can be called a nested query as well. There are many names. Okay, so what we can do is that select name, let's say, okay, I want to select the name of the students from student. Okay, where student id in. Okay, I'm using a very important clause known as in clause is where I can give many values as a list of values. So let's say 53611, 53633, and so on. So if I give this value, I get a long list like this. Okay, because These are the names of the students where these IDs are matching. Okay, I can also do something like this. Rather than in, okay, I can use something which is not in, and then it is going to give me the other way around, right? So I just want to look at the names of the students who have enrolled in some course. I know I can do this using a join. You've already done that, right? I can do this using a join. I can join the students table and the enroll table, and I can find this out, right? But instead of doing a join, can I do this using inline query? Okay, or can I do this using nested queries? Okay, the answer is yes, I can do that. I just have to replace this answer. I just have to replace this part of the query with some query. Okay, so what will be the query to get the student IDs from the enrolled table? Select distinct SID from enrolled. Okay, why did I do a distinct SID? Why did I use a distinct clause? Is because I just want to be sure that even if there are multiple, or let's say duplicate entries which are there in the enroll table, I am able to figure out. Okay, I am able to get a distinct list of the columns. So the output of this query, okay, is going to be a distinct list of student IDs, which is getting passed. Okay, which is getting passed as an input. So output of this query is now getting passed as an input as a where condition on this SID column, the SID column that belongs to the students table in the outer query, right? So this part of mine, okay, this part of mine, or maybe right, the entire part, okay, this entire part, this is actually a wrong drawing. So this entire part over here is my main query, or it is also known as an outer query. Okay, this is also known as an outer query, and this little part, right, which is inside my brackets, this is known as an inner query. Okay, it is also known as a subquery. So using a subquery is a very good way, but it is not always really efficient because the way a database executes this in clause and the way a database executes joins is going to vary. Okay, there are many databases who supports joins, right? There are many databases who are slow when it comes to joins. If you increase the number of joins, then the amount of time it's going to take to execute a query and give you back the results is going to increase, let's say, dramatically as compared to using an inline query. So it depends on as to what kind of cardinality of data. Okay, what kind of cardinality of data you have, and the basis that you can select this. Because in our case, in any of both of the cases, it's going to work because this inner query, right? This inner query is fetching how many? Maybe 3 or 4 rows. Okay, at max we are fetching 4 rows. So the data of the inner list is very small, and that's why this in clause is not going to search through a lot of the results, right? It's not going to take a lot of results as input, and then it is not going to search in students table, right? Had it been the case that let's say you have I don't know 5,000 students, right, and the output of this inner query is also, let's say, I don't know, 1.5 thousand. Okay, then you are scanning 1.5 thousand records out of 5,000 records. Okay, this is going to be a concern because there are a lot of data. Now 5,000 records as of day is really small. Maybe this example was not really good. What about I have 5 million rows, right? I have a table which is of 5 GB of size or 20 GB of size, then it is going to take a lot of time. So as the cardinality of the data increases, or the size, the dimension, the space of the data increases, in query inquiries are not to be used. You have to format, or you have to rewrite the query in such a way that the query is really efficient while you're working with the database. Because you may not realize, but this query, right, this query might be something that you're going to fire every day, or it's going to fire every time a model is getting compiled. And before a model is getting created, you need some data to be given as an input, right? And that input is going to come from a query which is something like this. And that query might have an outer query where you have one inner query, and then you have another inner query, and then you have another inner query there, right? So what I mean by that is one outer query consisting of multiple inner queries is also a situation. If you don't tune this kind of queries, if you don't write them well, then it is going to be a problem, right? So that's exactly what we are doing over here. Let me just clear the screen and let me press enter. Right, so what it has done is it has simply selected the names of the students where I have some matching records, okay, where I have at least one entry in the enroll table, right? In other words, I can say I've got list of names, of students. Okay, I've got a list of names of students from the students table, or I've just got a list of names of students who are at least enrolled in one course or enrolled in at least one course, right? So this is an example of a nested query, right? Now, uh, okay, give me 1 minute. Okay, okay, okay. So there is one more thing when it comes to this query thing, inline query or let's say nested query, that is really very important for us to understand. Sometimes we might use this. I mean, there can well be cases where in this inner query, right? In this inner query that we have, we may have to use a reference of the table which is there in the outer query, right? There can be cases like this. Example given, let's say that I would like to uh, do a clear screen first, and then I would like to do a select star from courses. Okay, I just like to do a select star from course, and then I would like to do a select star from course where, okay, I'm going to show you a new filtering condition which is called not exists. Okay, where not exists, and I'm going to explain what this not exists is going to do. Okay, just give me 1 minute and it is going to be entirely clear. So let's say I'm writing select star from course C or course, okay, where not exists, select star from enrolled. Okay, enrolled is the table where course dot cid is equal to enrolled dot cid, right? What this is actually giving me, what is this actually giving me is as simple as, if you look at the enroll table, okay, then you will get the answer very clearly. You look at the enroll table, you have course id 1, 2 and 3 which is allocated, okay, to certain student ids, but you don't have the course id 4 which is allocated to any user or to any student, right? To do that, what I'm doing is I'm simply running a query like this. Select everything from enroll table where the course.course id, outer table.course id matches with the inner table.course id. Right? This inner query now returns all the rows from the enroll table where there is a matching condition. Oh, sorry. In this case, because we are using not exists, right? That's why there is an unmatching condition. So wherever there is no matching entries between course and enrolled, this is this key. The key used here is CID. We have got the output. So clearly algorithms is one such course, although there is a spelling mistake here. And I will be correcting it when we look at DML. So this is one such course. Okay, algorithms is one such course where nobody, okay, absolutely no student is enrolled in. Okay, what if I just change this not exist to exists, right? If I change this to exists, clearly I'm going to get a list of all the courses where there is at least one student which is enrolled, right? Usually, just a tip, usually this query syntax exists and not exists, right? This works really good. Okay, this really works good. This query is really good when it comes to performance. It's just a bit difficult to understand at the first place. The moment you have got the gist of it, right, then it is really easy, right? The moment you have understood the structure, the schematic of how this exists and non-exists thing is working, then it becomes really very easy and it becomes very fast as compared to in clauses, right? As compared to in and not in that we have seen earlier. This usage of exists and not exists is really, really very good. Okay, I would strongly recommend that you can look at, let's say, blogs on the internet and you can try to find out if there are examples, and I'm also going to share those examples. Okay, from time to time I'm now going to start sharing, let's say, things which are related to the exercises that you can do with respect to SQL, right? So I'm going to be sharing that on our Telegram group. In similar lines, we can try to find out other exercises or other questions from online forums which we can use to find this out. right? Now that we have done this, let's take a quick pause and let's see if there are any queries from your side. If there is any query, we can try to resolve it now.
No queries.
Okay, okay, then let's make it a start. So what we are going to look now is something that I have to explain first, and then we can go ahead. So this is a very important concept. Okay, this is a very important kind of functions that people sometimes ignore. Okay, but this should not be ignored. Okay, these functions. Okay, these functions are otherwise known as window functions. Okay, what is the meaning of a window function? Let's see. Okay, it performs. I can clearly say it performs a calculation. Okay, a window function is as simple as it performs a calculation. Okay, it performs a calculation across, okay, a set of tuples, okay, or a set of tuples or columns which are related to a single row. Okay, this is similar to an aggregation. It sounds similar to an aggregation at the first place because it is performing a calculation, right? The moment we hear the word calculation, we of course we the first thing that comes to our mind is kind of an aggregate function like sum and average and all these things. But it's not entirely similar to that. It's a bit, let's say, different. Now, the biggest difference, what is the difference? I can say, what is the diff between then a window function and aggregation function? Okay, the difference between these two things is in case of uh, window functions, in case of a window function, okay, the tuples or columns, okay, are not grouped into a single output table or tables. What I mean by that is when we did an aggregation function, if you remember, we have to do group by. If we don't do group by, things will become messy. Okay, it will not accept my query at all. I have to do group by. The moment I group by, what is happening is there is a aggregated field and there is or a set of non-aggregated fields. So one or more non-aggregated fields and one or more aggregated fields. The aggregated fields will be grouped as per the non-aggregated fields. Right? Example given, if I'm trying to find, let's say the cases where I have duplicates in number of courses in a table. So what I'm going to say, select name comma count star or select name comma count of name. Okay, so in that way I should be able to find out the name and the count of that name that appears in that table from the course table group by name, right? So that's what I'm doing. We are creating an output table which is grouped by name, but in this case, the output will not be grouped into a single output table. Okay, so that's the biggest difference. Okay, let's see how this works. And then we should be able to understand how this works. Okay, so what the syntax looks like. Okay, what the syntax looks like. Okay, the syntax of a window function is something like this. So we do select and we select something, 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 and we use some function. Okay, we use some function, and then we use a clause called over. Okay, we write something inside over. We pass some values inside this function, obviously, right? And then we say from our table. Okay, so this is the query. This is the kind of query that we fire. So I'm selecting a certain set of columns basis my requirement, right? And then I am giving it a window function which runs over a certain thing. Okay, we are going to define what this thing is. It runs over a certain thing and it applies over all the rows across all the tuples that I've selected without grouping them into a single table from this table. Right, so this is exactly what we are doing. Okay, this over thing, okay, this over thing that I'm doing over here, right, this over clause that I'm doing over here, it is simply similar to how we used to slice the data. Okay, how we used to slice data into Python. into Python lists. If you remember, in case of Python lists, we used to slice the data something like this, right? So we used to use a function which is something like this. We used to have, let's say, list is the name of the variable where I have some data, and then this kind of an operation is going to select some output of it. Or I can have another list, let's say L2, and there I'm going to do, sorry, um, 1 comma 2, right? So this kind of a thing I can do. So this is kind of slicing that we've seen in Python. Similarly, this over function gives a slice capability or slicing capability, and then it also gives the capability to sort the data, right? So I can slice the data, I can optionally also sort the data using this over function and the things that we are going to put inside its brackets, right? Now let's look at an example, then all of our doubts will be cleared. Okay, if we look at more examples, then we can look into this. Okay, let's write, okay, let's write a window function where I am not going to give anything inside this part. Okay, so what I mean by that is, ideally, this portion here, right? Anything which goes as an input to this bracket of this over clause is actually optional. Okay, if I want, I'm going to give the value. If I want, I'm going to keep this empty. Okay, if I keep this empty also, the function is going to give me an output. Okay, let's see a kind of a row function and its uses. So I'm doing a select star. Okay, I'm not doing anything more. I'm just doing a select star. I'm going to select all the rows and also the output of a window function called row number over nothing as row number from enrolled. If I do something like this, it's simply giving me a sorted list of row number. It's kind of a serial number, right? It's kind of a serial number. Serial number is something which is there in any Excel table or any other sheets that you have seen, right? So I'm simply trying to output a row number. I'm giving a sequential number to each and every row, and this is a very easy way, right, of doing that. I'm simply selecting the row number, and then in the over clause, I'm not providing any input. Give me 1 minute. Okay, so this is one example. So what we have done over here, is we have selected a set of columns, and then we are treating this function, this window function, also as a column, right? So this entire thing over here, right, row number in brackets have not passed anything because this window function does not require any input. And then I've given it an over clause in this case because anything that goes inside the bracket of an over clause is also optional. So I'm not passing anything inside the brackets, right? Because we have already said this part of the over block is actually optional. Now this becomes a new column. Okay, this becomes a new column other than already existing columns. I can also try to be very, very selective and try to select only, let's say, I don't know, the SID and CID. Right, that can be done as well. So simply put, this part that you see over here, this part you see over here is simply treated. It is just as simple as treated like a new column in the output. So we're not grouping, we are windowing. Okay, how we are windowing? This is one, and then I should be calculating this over blank. Over blank means all the rows. So over without any clause I have given over. So this over without any clause means do this activity or do this window function for all the rows. So it calculates the row number for the first row. It gives it value 1. Then for the second one, it says, okay, this is the second row. I'm fine. So it's fine. I'm just going to increase this 1 by 2 because I have to print the row number for all the rows. Okay, there is no filter condition which is applied inside this. There is no slicing thing that is applied inside this. So slice is basically considered as one kind of, let's say, filtering operation that we can do. And then on the first row I print the row number as 1, on the second I print the row number as 2. Now after it has printed row number 1, to print row number 2, it is taking row number 1 as the reference, it is printing row number 2. Now row number 1 and 2 are printed. Now it is taking these two rows as a reference to print the third row. Right now it is taking these three rows to print the reference as fourth row. Are you getting my point? This is how the window function works. So at the first place, it returns this output. Then from this output, it gets this output. Then from these two rows, it gets this output. Then from these three rows, it gets this output. This is the reason why it is called a window function. You see, it is progressing. Okay, it is progressing as if you are closing a window. So when you're closing a sliding window, you're simply sliding over the record. So that is exactly what it is doing over here. So basis the kind of window function that you've used over here and the kind of slicing of the limitations and the sorting that I've put over here, which is optional. Okay, this is clearly optional. If you want, you can give, right? So this function will get executed over each and every row. It's not like I'm simply doing an aggregation where I'm taking a sum or an average where everything else has to be grouped by this aggregate, right? So that's the difference between a window function and an aggregate function. So let us look at some more examples. Okay, so let us look at another example. I'm going to fire the query first and then I'm going to explain you. Okay, I just want to know, right? I just want to know if I can output, okay, the records inside the enrolled table. Select star from enroll. Let's just look into the enroll table first. So I have 4 entries there. So I just want to uh, print out, I just want to represent the data that is inside this enrolled table and give it a row number, right? But I would just like to partition this data based on the course ID, right? Why course ID is because I know student ID is one thing, grade is also one thing that can be partitioned over, but course ID is something which may be kind of a unique thing, right? Which can be kind of a unique thing, but it can also have repetitions as well, because enroll table is where I have multiple students records who are enrolled into multiple courses. Like clearly you can see the first two rows. The first two rows we have a very good example that there are different students enrolled in the same course, right? If you look at these two rows. And then there are the next two rows where I can clearly see there are different students. No, I'm sorry. There are same students who are enrolled for different courses, right? Even there is one more example where I can clearly see there are two different students enrolled in the same course ID, which is one, and they have got the same grade. And so there is kind of a very good mix and match of data in this case because it's kind of a joint table. This enroll table, okay, this concept of an enroll table is also known as a joint table. Okay, this is a joint table. Why is this a joint table? Because this table here in this case it is enrolled. It is actually a joined output. Okay, it is a joined output of students and the courses table. So from the students table, what have we taken? We have SID in the students table, right? We may also have the grade. Okay, we may also have the grade in the students table. And then we have the course ID, which is there in the course table. It is not always mandatory that we are going to have a column from each and every table. Example given, we may not have, right? We may not have any columns from the student table which represent to grade. Grade may be something that we have added in this table, right? But a joint table is where there are multiple, okay? There is this multiple tables from where we are picking up columns from each and every other table, and then we are joining them and creating a distribution kind of table, right? So now let's try to fire this query that I want to fire, right? And then let's see how or what kind of interesting output it gives me. So select, I just want to know the student ID and the course ID, right? And I also need the row number. Okay. One interesting feature in MySQL, you can press enter and you can go to the next line and you can continue writing the query. Unless and until you press the semicolon sign, it's not going to stop, right? Right. So let's do this. Let's try to run the query. So select SID, CID. These are two fields which are there in the data column. So these are the tuples. I've selected this, and then I'm selecting row number. Again, the same. Okay, row number. This must be in caps, I believe. So let me just write it in caps. Over. Now inside this, what I'm going to write is something I'm going to explain later on. Partition by course ID. Right? So this is something I'm going to explain. Okay, how it is working. If you look at the output, you'll understand anyways. Right? But I'm also going to explain. Row number over partition by course ID from enrolled. Okay, order by course ID. Okay, look at this. So what is happening is it is partitioning the data by means of course ID. Right, it is partitioning the data by means of course ID, and then it is ordering it by the course ID. Right, what this essentially is doing is this partition by clause, right? It is grouping the data. It is simply grouping the data basis the course ID. So it is giving this as one group, and then it is also giving the others the other groups, and then according to the groups to which they belong, it is giving you the row number. So now the row number is not a constant list of 1, 2, 3, and 4. Okay, it is simply a grouping that it has created. Okay, how has it created the grouping? Because I have asked to create it based on the course ID. Okay, now because I have a very foolish kind of a course ID, that's why this query output also looks foolish. Then why not I just change this, I clear my screen, and then I simply select it as student ID. Right, if I do it along with, let's say, student ID and order also by student ID, let's see what it is doing. Okay, this is one cluster, or this is one row, one group that it has created. Okay, and then it has created another group which is belonging to this. Okay, this may well be dependent on certain factor. Okay, what if I divide this by means of grade? Right, it is simply doing a partitioning. If you look at this, it is grouping the courses, or it is grouping the identity, the ID, the people that I have given. This is one factor, right? So exactly that is what I'm doing over here. So it is simply grouping it. That's all it is doing. Right, now if I just go back to my original query and I do an order by CID inside this. If I'm doing an order by inside my over clause, and for each and every row, it is looking at the previous row and it is creating that order. Right, and that's the reason why the output here, obviously the output is exactly the same as not putting anything. Right, because to maintain the order, or even if I don't specify order by CID, it's anyways going to maintain the order. Right, so that's the use that I can do over there. Right, now let's try to take a more practical example, and we will find what is the good use, okay, of using a window function. So let's say I have a question: find the student, or maybe there can be more students as well. Okay, where or with, okay, where or with the highest grade for each course. Okay, think about this for a moment. Find the student. I need the detail of the students, which or who, the student who has the highest grade in any course. Okay, whatsoever courses they are enrolled in is irrelevant. They may be enrolled in 2 courses, he or she may be enrolled into 10 courses, but there is that one student who has got the highest grade for each course. Is like the topper of the class. He's like the topper of the batch. How do you do? This is a bit of a complex kind of a query. So we will go step by step. This query is going to involve an inline query or a kind of a subquery which can be written as something like this. So I'm going to select something from, and then I'm going to write another query. Right? And then I'm going to use a where clause. Okay, when you see the output, you will come to know. But this query definition, this query structure is really very difficult. Right? So let's start with the middle part. Let's first take this query, execute this over here. And then we can select whatever we want to select and do some kind of a where clause, and then we can find out. Right? That is going to make our understanding clear. So let's write the inner or inline or subquery first. Okay. My subquery is going to be something like this. I want everything and also the rank. Okay. Rank. Okay. Rank function is something that I'm using over. Okay. Partition by course ID, order by grade, ascending. So I'm selecting all the data and then I'm applying a window function called rank, which will be partitioned by the course ID and then ordered by the grade. And I'm going to call this as rank from enrolled table. Okay. Let's see what mistake I've done. And the right syntax to use. Where is the syntax issue that I've made? Rank. Oh, select star. Okay, comma. Okay, rank. Okay, over. Okay, partition by CID. Fine. Order by grade ASC. Yes, as a rank. Okay, fine. Okay, it is not taking the alias. I don't know why. Right. So that's the rank that it has actually given me. Okay. Now I'm just going to do a select star from, and I'm going to use a bracket. Inside this bracket, I'm going to give this inner query. Insert, right, as rank from where, or as ranking. Let me call it as ranking. Where ranking dot rank is equal to 1. Okay. Yeah. Obviously, I thought there is some problem over here. It's really very complicated to debug, man. This ranking dot rank is equal to 1. This as rank is not working. That is where the problem is. I don't know why. Let me just do it in separate lines. Okay. Select star rank. Sometimes using formatting it works. Rank over partition by course ID. Okay. Order by grade SC, and I'm going to call this as rank. Okay. From I'm going to say from enrolled, ENROLLD, enrolled. I'm going to call this as ranking where, okay, where ranking dot rank is equal to 1. No, I think it is still not taking this, and because of this I'm not able to put a filter outside. Okay. I think there is some problem with this MySQL syntax because I'm using the latest version. Maybe that's why there is something which is extra in this latest version which I am not aware of. Right. So let me work on this offline. Maybe there is some very simple, silly mistakes. Maybe I can also post this query over. Right. Let me just paste the query over here as well. Yeah. Let me just paste it to you as well, Ravi. Let's see if we can solve this. Let me just paste it over here. So this is the query that I'm trying to use. Let's see if any one of us can solve this. Yeah. Okay. So I hope you have got to the point, right? So the earlier functions that we have seen is where we are using ranking or we are using the ordering or we are using, let's say, the partitioning and so on, and we are just trying to break down. Okay, we're just trying to group the data without actually grouping the data, so without using any group by clause or anything of that sort. I'm simply trying to partition the data or by rolling over to that data, right? I think that problem we can resolve by tomorrow. Let's call it a day.
Thank you.
Thank you, Rohit. Thank you.